Hello and welcome to this video. In this video, we will study some important results, some important concepts from group theory. The first one is addition modulo n, second is multiplication modulo n, and the third is Zn is a group under addition. Okay, we start with the definition of addition modulo n. Okay, if we take any two integers a and b belongs to z, we all know the traditional or the usual addition of a and b. But the addition modulo n is an operation, binary operation, that is operation of addition modulo n for any two integers a and b belongs to z. The a plus b, that is sum modulo n, is denoted as a plus b mod n or modulo n, and it is defined as that whenever we will add a plus b modulo n is the remainder of ordinary sum when divided by n. And similarly, the multiplication modulo n is a multiplied by b is the remainder of ordinary product when divided by n. Okay, let's understand this concept with the help of an example. Suppose this n is 7. N can be any integer, and ba is equal to 5 and b is equal to 4. We know that the ordinary sum of ab is equal to 9 because 5 plus 4. But if we divide this 9 with 7, we will get the remainder 2. So a plus b will be equal to actually 2 mod modulo 7. Or if we take a is equal to 12 and b is equal to, let's say, 7 or 6, we get ordinary sum a plus b is equal to 18. But if we take, that is actually congruent to or equivalent to 4 modulo 7, because whenever we will divide this 18 by 7, we will get the remainder 4. And similarly, if we take a multiplied by b, that is 12 multiplied by 6, which is actually equal to 72, and that will be congruent to 2 mod 7 or modulo 7, because the remainder of 72 when it is divided by this 7 is 2. So now I hope we have understand the concept of modulo addition modulo n and multiplication modulo n. Next we move toward the Zn group. The group Zn is called the integer modulo n, and this is one of the most fundamental and most commonly used or encountered algebraic structure. Okay. Clearly, Zn is the set which is consists of up to so on n minus 1, because whenever we will divide any integer by n, we cannot get the remainder greater than n minus 1. So it can be 0 or 1 or 2 or up to so on n minus 1. We can see that a minus b will be congruent to 0 modulo n whenever the remainder of a modulo n and the remainder of b modulo n will be equal. That's why we can see that a is congruent to b whenever a minus b is divisible by n. Okay, now we see the structure of the group Zn. We check the properties of group. Consider Zn, which is equal to 0, 1, 2 up to so on n minus 1. Then the first property is Closure law. For all a b belongs to Zn, again we can see that a plus b mod n belongs to Zn, or associative law. That is, it is inherited from the associativity of integers. Then identity, it is very clear that this 0 will play the role of identity. The element 0 satisfies a plus 0 is congruent to a mod or modulo n. In short form, we write it as mod. Okay. And the last is inverse. The inverse of a is n minus a for all a belongs to Zn, because except 0, because inverse of 0 is again 0. But we have to check that this a and n minus a both are inverse of each other. We can see that if we add these two, we will get n, which is congruent to 0 modulo n, because whenever we will divide this n by this n, we will get the remainder 0, and 0 is the identity element. So it is clear that Zn is group under addition, not only group, but it is abelian group, because we can see that a plus b is equal to b plus a mod n. So I hope this video is helpful, and if you find this video helpful, then please subscribe the channel and like the video. Goodbye. We will see you next time.